So hello everyone. Today we are going to solve Dijkstra algorithm. Uh, so the problem statement is basically Dijkstra algorithm is marked as medium on Geeks for Geeks. The problem statement is given a weighted uh, given a weighted, undirected, and connected graph. Weighted means every edge has some value, has some weight, and undirected means these edges have don't have directions, or you can say they are both directional, two-way directional. You can go here and here also at the same time. No, not the same time, but you can go here and here also. And connected graph means every node in the graph is connected, right? Every node in the graph is connected like this. No one is left over. Everything is connected. Every node is connected. Where you have given an adjacency list adj. Adjacency list mean the list that contains every node's adjacent nodes. You have to find the shortest distance of all the vertices from the source vertex src. So you have to find the shortest distance from the source vertex and return a list of integers denoting the shortest distance between each node and source vertex source. The graph does not contain any negative weightage. Okay, so this is the adjacency list you have been given, and this is the source. Okay, so this is the source. From source to, you have to find the shortest path from these two nodes to this two node, and you have to return. What do you have to return? And you have to return a result array, and a result array that contains the shortest path from the vertex to. If I give like in this example, you can see that this is the adjacency list for this graph, and this is the index 0, this is index 1, and this is index 2, right? Wait, let me write it in more clear way. Okay, sorry. uh, Let me delete this. Okay, so you can see this is for index 0, this is for index 1, and this is for index 2. So at the index 0, this node is 1 and this node is 2. What does that mean? So from index 0, the adjacency nodes are 1 and 2. You can see from 0 the adjacency nodes are 1 and 2, right? This is the weight, with weight 1, like 0 to 1 is 1 weight, 0 to 2 the weight is 6, like this one weight is 6, here the weight is 1, and here you come this is for node 1. So from node 1, node 1's first adjacency node is 2 and second is 0. So this is the node 1. First adjacency node is this 2 with weight 3. You can see with weight 3, and adjacency list, this one is adjacency node 0 with weight 1, this one, right? So, and this one is for 2, similarly this one is for 2. Now this is just the representation of this weighted graph. Now this is the output. So how does this output come? You can see the source have been given to us, which is 2. So from 2 to node 0, what is the shortest path? What is the shortest path here? From 2 to node 0. Let me change the color. From source to node 0, what is the shortest path? If I go in this path, the distance is 6, right? 6 unit. If I go through this path, what is my distance? Here is 3, and 1. 3 plus 1 is 4. So this is the shortest path. This will be my shortest path from 2 to vertex 0. So that's why the answer is 4 is here. Now from 2 to 1, what is the shortest path? From 2, let me change the color. From 2 to 1, what is the shortest path? This one, right? This one the shortest path, and the cost of this path is 3. That's why here 3. Next from 2 uh, from 2 to 2, right? From source to source, what is the cost? Obviously 0. Obviously this will be 0 because you are not going anywhere. You are from 2, you are starting your journey, again you are reaching 2. So the displacement is 0. That's why this is 0. So what the approach? Now let's come to the approach. What should be the what could be my approach, right? Let's come to the approach. Let me write here approach. Okay, so first you have to visit the source node, right? So this you have to return this output. So first create this. Let me create so this is my final result. This will be my final result. Okay, this one for my vertex 0, this one is my vertex 2, this one will be my vertex 2. So at first I'll store infinity here, right? Let me write it with another color. Okay, with this one will be infinity, right? At first set everything infinity, right? From source 2 to distance 0 to vertex 0, the distance is infinity. From source 2 to vertex 1, the distance is infinity, and this one is infinity too. Now we know that from source 2 to 2, the distance, what will be the distance? See, the distance will be 0, right? So write 0 here. This will be 0. And now I will maintain another data structure here called mean heap, right? This is a mean heap. And why we are using mean heap, I will explain it later. Mean heap, or you can say priority queue. Priority queue. I will explain it later. Why I am using mean heap, I will explain it later. Okay. So whenever I get a shortest path, I will store that in my mean heap. So from 2 to 2, I have got a shortest path which the distance is 0, right? So I will store that here. So let me write here, the distance is 0. I will store here uh, 0 distance of vertex 2, right? Zero distance of vertex 2. Now what will I do is I will pop this one out, and I will go to this vertex, 2 vertex. I will go to 2 vertex. So let me pop. So I will pop this one. And I will go to this vertex, 2 vertex, and I will explore all the elements that are adjacent to this, right? All the nodes that are adjacent to this node. So I will explore these neighbors 0 and 1. So 2 to 0, what is the cost? The cost is 6. From 2 to 0 the cost is 6, so I will update here 6. I will write 6 here, right, and I will store that in my main heap. 6 comma 6, okay, 6 comma the what is the name, 0, 6 comma 0, right. Next I will go to 1, not go, I will just check from 2 to 1 what is the distance. The distance is 3. Okay, I will store 3 here. Now store 3 here. From 2 to 1 the distance was 3, right. Okay, all the all the vertices are visited that are adjacent to the source node. Okay, no, first let me update here. From 2 to 1 I have found a better path, so I have to write it here. Okay, 630. Now pop this one out, right. So what I am doing is I am first visiting a node, then I am exploring all the adjacent nodes and checking which is the minimum distance node, and I am going to that node, and again I am visiting all the adjacent of that node, and again choosing that node which is the closest to that node, right, like I have done in this situation. So I am using the min heap so that I can find the minimum distance and adjacent node in order of one time, because min heap contains the minimum element at the top of this data structure, right. So that's why I am using a min heap, or you can say priority queue. Now, sorry. So this is my priority queue. Now I will pop this one out 3. I will go to the one node which is at distance of 3 from my source, right. 2 to 1, I will go to this one. So previously my cost was 3. Now from 1 to 0, what is the cost? 1. So my 2 to 0, what is the cost? 3 plus 1, that is 4. Sorry, 2 to 0. 2 to 0, what is the cost? That is 4, right. But here it is 6, so I have to update it with 4, right. I have found a better way than previously it was 6, now it is 4, so I have found a better way, so I have to update here too. So update, I have found a way which distance is 4 from the vertex 2 to vertex 0, right. To vertex 0. Now so once adjacent node now is 2, so from 2 to 1 and 1 to 2 I have to come to 2, so the distance is 6. So 2 to 2 distance is 6, but here it is 0, so I do not have to update because it is the best one, so I do not have to update. Now once all the adjacent are visited, so now go to the minimum one. What is the minimum one from 1 to 0? Now what is the minimum one? In order to find the minimum, I have to pop this one out 40. I have to go to the node 0, right. Go to the node 0, pop this one out. Now go to the node 0, right, from node 0. Now let's check if I am finding any better route or not. Like in the adjacent of 0 is 1 and 2, right. The adjacent of 0 is 1 and 2. This 1 and these two are the adjacent of this 0. So from this 0 to 2, right, what are the path? I have gone 2 to 1, next 1 to 0. Now I am going 0 to 2. What is the cost of the path? Here it was 3, here it was 1. 4 plus 6 is 10. So from 2 to 2, again 2, I am reaching 2, so the distance is 10, but it is 0, so it is the better one, no need to update. Now the other adjacent is 1. So what is the cost of this path? So I have gone 3, 2 to 1, 3, next 1 to 0, 3 plus 1 is 4, and I am going back here plus 1, right? 3 plus 1 4, again coming back plus 1 6, 3 plus 1 4, 4 plus 1 5, sorry 5. So 2 to 1, this path costs me 5, but here it is 3, right? It is 3, so this is the best one, no need to update, so don't update, and all the adjacent are visited. So you can see my answer is 430, and here the output was 430, right? So this is how you have to solve the problem. So let's code this. Let's code this on the Geeks for Geeks. Okay, let me maximize this and let's start to code. So first create a priority queue. priority queue of int comma vector of int comma greater of int, name it as pq, and I have to store instead of integer, I have to store pair, because here you can see in the priority queue what was the I what was I inserting? A pair, right? 6 comma 0. I was expert inserting the elements in the form pair, in the pair form. So I have to here declare it as pair, int comma int, right? Replace all the integers with pairs. Sorry, copy, control C, B, and this one too. Okay. Now create the result one. The result variable will be vector of integer lt result, and then what will be the size? Let me first take the size out. Int n, size means the number of nodes. adj dot size, adj dot size. Now name it as source. What will be the size of my result array? N, right? N, and first what was I doing? I was storing all the values infinity, right? Int max. So infinity means int max. Now what do I have to do? I have to iterate. I have to keep going until my priority queue finishes, right? And here one more thing, initialize the result of source, right? From source to source, what was the distance? The distance was 0, right? The distance was 0, and in the priority queue insert, what do I have to insert 0. The distance is 0 of what? Source node, right? From source to source node the distance is 0. That's why I know it previously, that's why I am inserting in the priority queue or in the mean heap. Now create a while loop. while pq not empty, while my priority queue is not empty. Now what do I have to do? Okay, while the priority queue is not empty, I have to pop this one out, right? So if I pop this one, so I have to go to this node, right? And this is the cost, and this will be my cost, or you can say the distance, right? So I have to pop this one and go to that node. So let pop, or while I'm popping, uh, let me, okay, int u. My priority queues, first value is the distance. First value is the distance from source node, right? So I will store that as distance. Distance is equal to pq, priority queue dot top. In the top, the distance, the first one is distance, so I will do what? I will do first distance. Int, I will name it as node, and node will be equal to pq dot top dot second, right? And I will pop the element pq dot pop. Okay, so what I am doing is I am finding the distance that is in the shortest, that is closest to my current node, and this is the, and that this is that node that is closest to my current node, and I am popping that element, right? Now what do I have to do now? uh, Now I have to go to the every adjacent element of my of that node that is the closest, right? This is the closest, so I have to visit all the nodes of this node. So what do I have to do is I will create a for loop for auto auto break in. Why break in adj of node, right? For this node I'm trying to go to the all the adjacency nodes. So this so adjacency, let's see what is my this adjacency of node. So you can see that uh, adjacency node, adjacency matrix is my 3D array, right? So this one will be my 2D array. 2D array means vector of vectors. So this vector will traverse every vector in the this 2D array. So vec means vectors, and this vector is nothing but a pair whose first value is the node and second value is the weight. So So what do I have to do is, first value is the node, right? So I'll go to that node. I'll go to that node and calculate the distance. I'll go to that node and calculate the distance. What do I name it? Int. Let's name it as nd. Int nd is equal to vec dot first, vec dot first, and int wt, right? The weight of that node is what? Vec dot second. So this is this is the node vec dot first, and this is the weight of that node, which is vec dot second. Now I'll do what if this was the distance from my source node to the current node, and here I am exploring all the adjacent to this node, right? This is my current node. So if the distance, okay, so I'll check here, and if the distance, if this distance plus weight is less than re, a result of what? So from this source vertex I am reaching to the current node, and from current node I am reaching to this node, right? So this is the node. So result of nd, right? If the if my current distance is less than my previous distance that was in the result, so I will update the result. Sorry. So I will update the result. I have found a better path, so that's why I'll have to update, right? Result of nd will be equal to, I have to update distance plus what? Wt, right? Distance plus Wt, and stored in the I have found a better path, so insert that in my priority queue with first will be what? First will be the distance. Distance plus weight, comma, the node, right? And at the end return the result, right? At the end return the result. Okay, so this was simple, right? Now let's try to run this. I hope this runs. Compilation error. What is the compilation error? Let me see. In member function Dijkstra, has no member named insert. Oh, sorry, this is my priority queue, right? So pq, there will be insert, push. Instead of insert function, this will be push, and in any mistake, insert. Okay, this will be my push. Okay, let try to rerun this. I hope no error occurs. Okay, compilation completed. Let's try to submit this. Submit. What happened? Pages, you can wait for them to become. What happened? Let's request already queued. Let's try to rerun this. Okay, compilation completed. Now let's try to submit. Why isn't it being submitted? I have to refresh the page. Wait. Let me refresh the page. Okay, now submit. I hope this passes all the test cases. There are 1112 test cases. Okay, great. I passed all the test cases. So this is how you can solve Dijkstra algorithm. So you can calculate the time complexity from here. The time complexity will be what? uh, at the worst, what you are doing here, you are inserting all the nodes in the priority queue. So at the worst case, you have to insert all the nodes, right? So this will be running for n time, and inside you are visiting all the adjacent nodes to the current node, right? So if that node is connected to all the nodes, so you have to visit all the nodes of the graph. So in the worst case, this for loop will run for n times, right? This will run for n time. Let me write here, big O of n, big O of n, and this will also run for big O of n, big O of n. So overall the time complexity of this code for this function will be big O of n square. uh, Big O of n square, big O of n square, right?